Good morning everyone. So last time we have completed Ohm's law, right? And according to it, we get one other thing which is related to the electricity, which is the resistance. So we have seen that the resistance is one of the property which depends on the atmosphere around it, and it is also depends on the material used for making it. So generally, if the object is conductor, means it conducts a current, then you can say that its resistance is less, and just because of that a high amount of current is flowing from it. But if the object is insulator, means it doesn't conduct current, then you can say that its resistance is high. So as the resistance high, the current flowing from it is less, and if the resistance is less, the current flowing from it is high, and it is because of the resistivity of that conductor. It is the internal property of any material, like a copper. Copper has a less resistivity, and just because of that it conducts a more current, while a plastic, rubber has a high resistivity, and that much high that the current can't be flow from it. So like that, you can say that the resistivity is the internal property of any material, which gives the value of resistance, that the how much resistance is higher or less, and according to it the current can be flow from it. So last time we have just seen that the resistor depends on the two things. One is the atmosphere around it, like what is temperature and the pressure and something like that, and another thing is the material, like a copper, iron, anything. Right? Copper, iron, aluminum, anything. Okay? So this resistance depends on the atmosphere around it and the material. When the material is generally stands in a form of resistance is the resistivity. Why does resistance depend on this material? Because material has some finite resistivity, which is the finite. The value of it is a constant for any material, like for a copper, it can be any value, for iron, aluminum, understand? So the resistivity is generally comes with the material, right? So which type of material is used by you gives you the value of resistivity, which directly affect the resistance. So this resistance depends on the resistivity. And this resistivity is dependent on the material, which type of material is used. And just because of that, this resistance is directly depend on material. Understand? Resistance depends on resistivity, while resistivity depends on material. If they are dependent to each other, then resistance directly depends on material. And just because of that, we can say that the resistance is changed due to the material or atmosphere around it. But there is one another quantity on which this resistance is depends, or resistance can be varied. Which quantity is that? That's a volume of conductor, or you can say that the size of conductor. How? For that, there is one activity is given to you. That, as you know, you have learned the Ohm's law, right? So first of all, you have to arrange the circuit according to Ohm's law, and then you have to put a material as a resistance in it, right? So I am just using that circuit, right? If I am taking a one material, a one rod of copper, a wire of copper, right? Here it is the wire of copper. It's a thin wire, but for understanding, I am just making it. that much larger that you can easily see it. So here it is one wire of copper. The length of that copper wire is L. Length of that copper wire is L. And the cross-sectional area of that is A. The cross-sectional area is A. Okay. Now I am just putting this resistance in the circuit of Ohm's law, and I am just measuring the resistance, and I get the value of resistance, which is R. The value of resistance is R. Now I am taking a same material wire, but length becomes large, right? So I am taking the same material of wire, but the length becomes large. Means the cross-sectional area is A, right? But length becomes 12. Length becomes 12. Now I am measuring the resistance with the same circuit, and what I get, the answer becomes 2R, double than the first one. Now I am taking a same material but a higher cross-sectional area. The length is same, which is L, but cross-sectional area becomes double, which is 2A. And when I measure the resistance, it becomes R by 2. If this activity is done by you, then what is the conclusions according to you? At here, I am taking the copper wire of length L and cross-sectional area A. When I measure the resistance, it becomes R. When I am taking a length twice than the first one, then I get the resistance which is twice than the first one. But when I take the cross-sectional area twice, then my resistance becomes half. What is the conclusion of it? What do you think about it? What is the conclusion from this activity? Just think about it. That you can easily say that there is some relations between this L and this R, this A and this R. But what is the relation? You can easily see it here. When the length increases, the R is also increases. And both are same. So both are directly proportional to each other. Right? Both are directly proportional to each other. Because R and L both increases in the same manner. If the length is increases twice, then the resistance also becomes twice. So R directly proportional to L. Not only that, when cross-sectional area increases, in the same manner the resistance is decreases. So both are inversely proportional to each other. So with the length, increment of length gives the increment of resistance. And if the cross-sectional area increases, then you can say that the resistance becomes decreases. So when I combine both of them, then I get R is directly proportional to L, but the inversely proportional to A. R is directly proportional to L, but the inversely proportional to A. And as I remove proportionality, I have to put is equal to and the constant. So R is equal to, it is called rho. It is called rho. Rho L by A. Rho L by A. Right? Rho L by A. Where the rho is known as resistivity. Rho is known as resistivity, which is the property of material, which is the constant. So this R depends on rho. According to this, R depends on L, length, R depends on A. L and A gives the size of conductor. So like that, the resistance depends on the size of conductor. Just because of that, sometimes that you know that the earthing wire, the plug of earthing wire is more thick than the other one, because as it becomes thick, the cross sectional area is increases, and it increases, the RS decreases. So the another current which is not necessary for us, or a leakage current, can easily go to the ground and we can't get the shock. Understand? So generally you have know that in a 3-pin plug, generally the plug of a third one means the earth wires plug, right, which is more larger than the other one, because cross sectional area is increases, R is decreases, so R decreases, current can be easily flow from it, just because of that. So like that you can use these properties of a resistance like that. Okay, so the R is equal to rho L upon A, where the R depends on rho L and A. Rho is the resistivity, right? So for that you can say that the R is directly proportional to the resistivity. So you can say that it depends on the material of an object. Which type of material we are using also gives the value of resistance. Not only that, what is the length and what is the cross sectional area is also gives you the value of resistance. If the length is higher, the resistance is higher. If the length is less, the resistance is less. If the cross sectional area is higher, resistance is less, and if the cross sectional area is less, the resistance is higher. So like that, this is the equation of R. So according to it, you can say that the R is equal to rho L upon A. So if I take a rho, then the rho is equal to RA upon M. So with the help of it, you can easily find out the SI unit of rho. Resistivity is SI unit, which is ohm. A is the meter square, and here it is meter. Meter cancel out, so it's ohm into meter. So the SI unit of a resistivity is ohm into meter. The SI unit of resistivity is ohm into meter. Generally for a conductor, it's from 10 raised to minus 12 to 10 raised to minus 8 or minus 6. But for insulator, it is higher. Right? For insulator, the resistivity is higher. For the conductor, the resistivity is less. And just because of that less resistivity, the current can be easily flow from it. Understand? So here it is your topic, resistivity. And from that, what you get? From this, what you get? That the equation for the R, another equation is R is equal to rho L upon A, where the rho is resistivity. From there, the rho is RA by N, and the SI unit is ohm into meter. The main thing is that the resistor depends on three things. Now, one is the atmospheric condition. Another one is the size of conductor. And the last one is material used as a resistor. But the resistivity depends on only one thing, which is material. Which material you have used, only on that the resistivity is given. While the resistance is depends on these three things that you have to know, because sometimes 1 marks of questions can be confused according to it. That sometimes you just think that the resistance and the resistivity are both same, but both are different. So here it is our topic, resistivity, right? The another topic related to the resistivity will be seen in the next